I am discussing about the how to calculate average value and RMS values of periodic waveforms. First of all, what is meant by periodic waveform? That is, the function f of t is equal to f of t plus t, capital T. That means the same function value will be repeated at every time period, capital T. That means the positive off cycle, negative off cycle will be continuously repeated at every instant T. That waveforms are called as the periodic waveforms. Then, what is the main formula to find out average value and RMS value? That is, we have to calculate the RMS value, average value of the function is, that is, area should be covered under time period. That is 1 by t integral 0 to t f of t dt. That is, we have to integrate nothing but the area covered by the within time period t, that is called the average value. That is area by distance. Similarly, the formula for RMS value. RMS means root, that is root mean. What is the mean? Average value. That is 1 by t integral 0 to t f of t and square. S belongs to square. That function square into dt. So this is the formula for RMS value. Root mean square value. By using these formulas, you have to calculate average RMS value for given every waveforms. For example, you have to consider periodic waveform. I am taking basic periodic waveform is sine and variable is voltage and x-axis variable is t. I am taking here. Then before going to average value, RMS value, you have to calculate what is the time period of the function of the waveform. That is where the function is to be repeated. That is called the time period. Then after 2 pi, the same waveform will be repeated. That's why you have taken the time period is 2 pi. And the function value, that is v of t, equal to, that is, what is the equation of sine waveform? That is Vm sine t. X-axis variable is sine t. For what are the limits here? 0 to t less than 2 pi. Like that. Then you have to find out average value for complete cycle of periodic waveform. That is, you can denote the variable suffix avg, average. That is 1 by t. That is 1 by 2 pi, 0 to 2 pi. Then Vm sin t into dt. Then you have to find out integration of the sign here. We know the integration Vm is constant, then take it outside Vm by 2 pi. The integration of sine theta, we know that is minus cos theta, then the limits are 0 to pi. Then minus is right on the outside minus Vm by 2 pi. Then apply the limits cos 2 pi minus cos 0. What is the value of cos 2 pi? That is plus 1. Therefore, minus Vm by 2 pi, cos 2 pi value is 1, cos 0 value is 1. Then 1 minus 1, 0. Then complete average value of the average value of periodic waveform is 0 for over a complete cycle. That is, average value of periodic waveform over a cycle, then that value is 0. Okay, this is very very important for when there is average value of the any periodic waveform over a complete cycle is 0. That's why we have to calculate the average value for the periodic waveform by taking only half cycle. That's why you have to consider for sine waveform only taken half cycle only. That is 0 to pi. The maximum value Vm. Therefore, average value. That is V average equal to what is the time period? Pi. 1 by pi and 0 to pi Vm sin t. X-axis variable is t. And with respect to differentiation, dt. Hence, Vm is constant taken outside. The integration of cos theta, we know that is minus cos theta. The limits are 0 to pi. From that, Vm by pi minus taken outside, that is cos pi minus cos 0. What is the value of cos pi? We know the value of cos pi is minus 1 and minus cos 0 is 1. Minus 1, minus 2. Minus will be cancelled. Then average value of sine waveform is 2 Vm by pi. This is the formula for average value of any periodic waveform. That is sinusoidal waveform is 2 Vm by pi. Like that, you have to calculate RMS value also. What is the formula for RMS value? The RMS value we are calculating for complete cycle. Why? Because it has square root. That's why there is no zero value. That's why the RMS value is the time period is 1 by 2 pi integral 0 to pi f of t square. That is Vm sin omega t whole square dt. That is t. X-axis variable t. That's why sin t. Then the whole function is square root. This is the formula applying the sine function. Vm is constant, then Vm square by 2 pi. We know the formula of sine square theta, that is 1 minus cos square theta by 2. Then integration 0 to pi. Then dt, that is whole square. Then apply the integration here. Vm by 4 pi. 2 is constant taken outside. For integration of constant t. For integration of cos sine t, sine 2t by 2. Then apply the limits here 0 to 2 pi. Hence Vm by 4 pi. Apply the limits sine 2 pi minus sine 2 into 2 pi 4 pi by 2 and 0 minus sine 0 0. Then this value also sine 4 pi also 0. Hence the remaining value is therefore VRMS value of periodic waveform is Vm by 4 pi into 2 pi, that is whole square. Total equation is whole square, that is Vm square. Then 2 times is cancellation. Then square root of Vm square is Vm by root 2. That is the formula for VRMS value of the sinusoidal waveform. That is Vm by root 2. We know the value of 1 by root 2 is 0.707 into Vm. Okay. This is the value of the RMS value of sinusoidal waveform. Okay. Here the very important point is the average value of periodic waveform over a complete cycle is 0. That's why for periodic waveform we are calculating the average value by taking only half cycles. And also we are find out same average value RMS value by considering another periodic waveform, that is square. Suppose this is current waveform, x-axis T, and this is Vm and pi 2 pi. Okay. Here, first of all, you can calculate the value of time period, that is 2 pi. We know over complete cycle average value is 0. That's why we are calculating the average value only by taking half cycle. What is formula? 1 by t. Okay, for half cycle, 2 pi will be replaced with pi only by considering half cycle values. That's why 1 by pi integral 0 to pi. From 0 to pi, what is the value here? Constant value. That is only Vm dt. Vm is constant taken outside. What is the integration of constant? That is t. 0 to pi. Then apply the limits here. Vm by pi, pi minus 0. Then pi will be cancelled. Therefore, for square waveform, the average value will be Vm. That is only by taking what is the maximum value given in the problem, that is the average value for square. Okay. In examinations, the waveform values are given. Vm value is given in terms of numericals and also pi and 2 pi. That is the time periods also replaced with values. Then by taking the values, you can take integration and simplify, then find out the average values as well as RMS values. In the same way, you have to calculate RMS value for square waveform. That is IRMS. What is formula here? That is 1 by t, 0 to t, that is f of t dt. Function is I. Here, the square waveform, that is whole square, function whole square, apply the limits, that is square root. Okay, that is the RMS value, nothing but the square waveform having two values, that is from 0 to pi. What is the value here? That is Vm square, positive value. Similarly, from pi to 2 pi, the value is minus Vm, that is positive value, Vm whole square. In this way, you have to find out, write down the equation for square waveform in RMS value. That is 1 by 2 pi. Vm is constant. That's why Vm square. For both equations, Vm square is constant. Then the integration is t 0 to pi plus, here also constant, integration is t, that is pi to 2 pi whole square, that is square root of whole term. Then similarly, Vm by 2 pi, apply the limits, pi minus 0 plus 2 pi minus pi here. 2 pi minus pi, pi plus pi, 2 pi. Then whole term will be cancelled. That is Vm square. The RMS value for square waveform will be Vm. 2 pi is cancelled. The numerator and denominator. Okay. In this way, we can calculate the RMS value of for square waveform also. Okay. In the problem, the university examinations also, you have to calculate average value and RMS value for the different waveform shapes, either triangular or sawtooth or sphere waveform. Okay, different waveform shapes are given. For further waveforms, you have to calculate the average value, RMS value. Please subscribe our channel and share to your friends.